Hi class, welcome to lesson 34. In this lesson, we will determine how strongly an atom of an element attracts electrons in a chemical bond using electronegativity values from reference table S. We will determine the degree of polarity in a bond based upon electronegativity difference between two bonded atoms. And finally, we will classify bonds in terms of polarity and ionic character. As a quick review, a bond results from the attraction of the nuclei of one atom to the electrons of another. Atoms tend to want to gain, lose, or share electrons to achieve a stable, low potential energy 8 valence electrons. Recall that the attraction for electrons in a bond is defined as electronegativity. Okay, let's talk about bonding and why it happens. So here we have an atom of hydrogen, and here I have an atom of chlorine. Let's first use our reference table to see if we can find out more about these elements. So hydrogen has an atomic number 1. So we remember that the atomic number is the number of protons in the nucleus. While chlorine has an atomic number of 17. So chlorine has 17 positive protons in its nucleus. Now, in order to know about neutrons, you would need to be given some more information. But the most common form of hydrogen actually has 0 neutrons, while the most common form of chlorine has 18 neutrons. Again, these are not really important because neutrons do not participate in bonding. Now, to find out more about the atoms, I can look at their electron configuration. Hydrogen has an electron configuration of 1, meaning it has 1 electron on its outermost shell, its single principal energy level. While chlorine has an electron configuration of 2, 8, 7. Since there are 3 numbers in the electron configuration, it will have 3 principal energy levels. So there will be 2 electrons on the first principal energy level closest to the nucleus, 8 electrons on the second principal energy level, and 7 electrons on the third principal energy level called the valence electron shell. 1, 2, 3. Atoms form bonds to obtain stable, lower energy valence electron configuration. When I look at hydrogen and chlorine, hydrogen is a nonmetal, as is chlorine, so they will form a covalent bond where they share electrons. Now, how does this sharing happen? This sharing happens because hydrogen's positive nucleus will go and pull on one of chlorine's negative electrons. So this force is called electronegativity. At the same time, chlorine's much more positive nucleus of positive 17 will exert an electronegativity or a force of attraction to hydrogen's 1 valence electron. Now, if we wanted to compare the strengths of the attraction for electrons in a bond, we can look up electronegativity on reference table S. So the electronegativity of hydrogen is 2.2. While the electronegativity of chlorine is 3.2. So we know that chlorine has a much stronger pull for the electrons in the bond between hydrogen and chlorine. Now, when these particles share their valence electrons, then this hydrogen will have a valence of 2, which is filled, and this chlorine will have a valence of 8, which is also filled. Today we're going to look at bonds, and bonds are either described as being polar or nonpolar. The word polar means different. So when a bond is polar, it is said to have 2 dipoles, or different ends. The greater the electronegativity difference of the atoms within a bond, the more polar that bond will be. Bond polarity is important because it can influence the chemical properties of a substance or how quickly it undergoes a chemical reaction. In order to calculate bond polarity, you're going to need reference table S and a calculator. All you have to do is subtract the electronegativity between the 2 atoms in a bond. If the electronegativity difference is 0, then the bond will be called nonpolar because there is no difference between the electronegativity values. If the electronegativity difference is greater than 0, the bond is polar. Now, bond polarity is on a continuum, as you can see in this number line. And on this number line, you can also see that there's a distinction between polar covalent and ionic. So if the electronegativity difference is greater than 2, a substance is said to be ionic. Though the easier way to characterize this, of course, is to simply use element distinction. So we know that ionic is always going to be metal and nonmetal. Again, since this is a continuum, you can see that we can have the characteristics saying that if there is no electronegativity difference, then the bond is not very polar and it is not very ionic. The higher the electronegativity difference, the more polar a bond is and the more ionic a bond is. So let's take a closer look at the different types of bonds and how they work. The first bond we'll look at is a nonpolar covalent bond. Recall that a covalent bond is a bond between 2 nonmetals that equally share their electrons. This happens because the electronegativity difference between the 2 atoms is 0. This usually only happens if the 2 atoms are identical, like in a diatomic element. Remember, you are responsible for knowing the 7 diatomic elements. I recommend you review them before your next quiz. Here you can see in the animation with hydrogen, each hydrogen atom has only 1 valence electron. But when they approach one another, their nuclei pull on each other's electrons, and then they share electrons in a nonpolar covalent bond. Notice how the electrons spend an equal time with each of the hydrogen atoms. A polar covalent bond is a bond between 2 nonmetals that unequally share their electrons. This happens when the electronegativity difference is greater than 0. When this happens, the element that has a higher electronegativity will pull the electrons closer to its nucleus than the atom with the lower electronegativity. So when we look at this animation and we look at hydrogen and fluorine, notice how hydrogen has 1 valence electron and fluorine has 7 valence electrons. Now, when they come together, their electrons are shared, but since fluorine has a greater electronegativity, the electrons will spend more time around the fluorine atom than they will the hydrogen atom. This will give the higher electronegativity valued element, in this case fluorine, a slight negative charge, which is indicated by this Greek symbol delta negative, and the lower electronegative atom, hydrogen, with the Greek symbol delta positive. This difference in charge is called a dipole. So we know that the first thing we want to look at when trying to determine the bond type is the element type. So it is not recommended that you use electronegativity difference to determine if a bond is ionic. Instead, simply look that if a bond contains a metal and a nonmetal, it will be ionic. If a bond has two nonmetals, then you're going to have to look at electronegativity difference. If there is no electronegativity difference because the atoms that are bonded are identical, then you will have a nonpolar covalent bond. If the two atoms in the bond are different, there will be an electronegativity difference. So the bond will be polar covalent. Let's look at examples. So here we have the bond between sodium and chlorine. The first thing to note is sodium is a metal and chlorine is a nonmetal. And although I can easily look up their electronegativity values and subtract, it is much easier to just simply say it's ionic. Now, since it's ionic, it is very polarized because it has a negative ion called an anion and a positive ion, meow meow, called a cation. Here you can see in the animation that when sodium and chlorine get near one another, their nuclei pull on one another's electrons. Since chlorine is much more electronegative than sodium, chlorine takes sodium's valence electron. Both atoms achieve a stable noble gas valence electron configuration. Now let's look at another example. What happens when chlorine bonds with chlorine to make the diatomic element chlorine? Well, if we look at the electronegativity difference, obviously the difference will be zero because the elements are the same. This is a nonpolar covalent bond. So when we look at our continuum, you can see that we first looked at ionic bonding, where there's a big difference of electronegativity. So ionic bonds are very polarized. Here we have a covalent bond, and this covalent bond is a nonpolar covalent bond because the two atoms are identical. Now, what happens when hydrogen bonds with chlorine? The first thing we'll do is we'll check that hydrogen is a nonmetal and chlorine is a nonmetal. So we know this will be a covalent bond. Then we'll look up the difference of electronegativity. Notice that the difference of electronegativity is really the absolute difference. So when I subtract these two values, I can just take the absolute difference in my calculation. So there's a difference of 1 electronegativity value between hydrogen and chlorine. This makes the bond a polar covalent bond. Now, what that means is that the hydrogen and the chlorine will share electrons, but they will not do so equally. The more electronegative chlorine will hold the shared electrons more often than the less electronegative hydrogen. Here we'll see that hydrogen, which has a lower electronegativity value, will be more positive in charge, and chlorine, which has a higher electronegativity value, will be more negative in charge, though the total charge of this molecule is 0. We know that when substances have a total charge of 0 through bonding, they have stable noble gas valence electron configurations. So when we look at the bonding continuum, what you can see is when there is no difference in electronegativity value, the electrons are shared equally in a nonpolar covalent bond. When there is some difference in electronegativity, then the electrons will be shared unequally in a polar covalent bond. And when there is a large difference of electronegativity, the electrons will be transferred to the more electronegative element, and an ionic bond will form. So recall that this is just a continuum. The lower the electronegativity difference, the less ionic and more nonpolar substances, or the higher the electronegativity difference, the more ionic and the more polar something is. So here you can see that the carbon-carbon bond, which has no electronegativity difference, has less ionic character because it is farther from the large electronegativity difference than oxygen-fluorine bond, which has more ionic character. Now, both of these bonds are indeed covalent, but they can have ionic character because the character just describes the relative difference of electronegativity. So to summarize, we know that we have three different types of bonds that describe how the electrons are shared differently due to their differences in electronegativity. In a nonpolar covalent bonds, because there is no electronegativity difference, electrons will be shared equally. In a polar covalent bond, the electrons will be shared, but they will be shared unequally. And in an ionic bond, which is extremely polarized, the electrons will not be shared, but instead they will be transferred to the more electronegative element. So by now you should be able to determine how strong an atom of an element attracts an electron in a chemical bond using the electronegativity values of reference table S. Just look them up, it's super easy. And you should be able to determine the degree of polarity of a bond due to electronegativity difference. That's it, folks. Make sure that you've taken good notes. Write down any questions you have and ask them in class. You can also bring those questions to support that we have throughout the week. Make sure you complete your homework in Google Classroom. And don't forget to put your Regents Chemistry reference table and non-graphing calculator in your backpack. They will be checked for classwork